Today, we are coming to look at something that is very important in the GIS industry, with those environments and other institutions that deals with spatial data. And this very significant topic is nothing else but georeferencing. When we are talking about georeferencing, we are talking about assigning geographic coordinates to scan maps and data sets. So that means that we make use of the longitude and latitude of the scan documents by assigning geographic coordinates to them so that we can align them to the real world context so that we can either integrate new information or extract some existing information from these scan maps into current data for further activities, for planning, for engineering, or any other spatial related activity. So you realize that georeferencing is something that is very essential and key when it comes to spatial data integration. For instance, talking about um, building footprints, land parcels management, and also integration of pipelines and road networks in the urban fabric. So when it's existing or old data. Now let's look at some of the importance of georeferencing. So for instance, we can provide spatial context. That is why what I was actually talking about, maybe trying to remotely sense your parcel of land, or as a planner, you want to incorporate some access roads whereby you need to georeference a particular local layout or scheme to be able to have access or to know where there is space for you to provide those infrastructure that you want to incorporate. So also talking about data incorporations with geographic information. So let's assume that what we talked about earlier. So you want to incorporate some data to an existing data. So you have an existing data that you want to incorporate some other new data sets into. Georeferencing helps you to do that. It also helps to improve accuracy in mapping and analysis. So let's assume that you already know that there are certain existing features in a particular place. So when you are mapping that particular area, it helps you to avoid maybe distortions in the raw material, raw spatial data that you already have. So enabling you to have precise alignment with your geographic layers. So it helps you to map very well and easily. So we also have analysis of historical maps. So let's say that you have a historical map that you need to analyze. These are maps that have been prepared for a very long time. And maybe coming across it for the first time, you need to look at how things exist today and how they were in the previous. So georeferencing helps you or give you the opportunity to do that. So now let's also look at some of the types of georeferencing that we have. So we have coordinate-based georeferencing. So to do this, you require coordinates that contains both latitude and longitude. That's having your X and Y. So it helps you to be able to georeference your maybe your analog data that you're having or a scan map. So when you have your coordinates, all that you need to do is to prepare your data set. Then you identify some various control points. So when we are saying control points, we are looking at some specific locations on your analog data and comparing that or creating a relationship between what is on your analog data, which is being converted into a digital format and incorporated into your GIS software. So you find a relationship with that in a real world context. So for instance, you have to open one of the base maps, be it Google Hybrid or Esri topography, so that you have a real view of the world, so that you can be able to align your control points that is from your analog data or your scan map to the real world context. So that is one of the steps you need to do. So you enter your reference coordinates. So your reference coordinates are going to be your control points that you'll be integrating. Then in georeferencing, there is something that is very significant for you to take into consideration, which is your transformation. So we have various types of um, transformations that you need to take into consideration. All of them comes with their own properties. I hope you are getting me. Are you getting me right?
Yes, please.
All right. So we have affine, and we also have polynomial transformation. So if you go into the QGIS software, if you look at the polynomial, it's being divided into three categories, whereby you have first polynomial, then you also have second and third. So all of them are having their features and how they operate. So when you select your transformation, the next thing is for you to georeference. So after running your georeference or your georeferencing, what you need to do is to assess your accuracy. To try to look at how the alignment that you have done using your control points. That is the relationship that you create between your your analog data or your scan map with that of the real world. So now you have to validate your georeferencing. In validating your georeferencing, you just try to look at the image that you try to georeference and ensure that there is accuracy in the spatial data set so that your error will be minimal. That is in relation to the control points that you generate. So when we are talking about ground control points, we are talking about some specific locations. Maybe it can be a football field, or it can be a school, or any other thing that you can use as a reference point, so that when you create a control point over there, it's going to pick the coordinates of that area so that you can easily use it for georeferencing. Because once you create a control point, it's going to pick the coordinates. And that means that it is a reference point that you have established. And you can always go back to it at any time once it's being referenced in that manner. So now once you georeference based on the coordinate base, then you can export your georeference data, then you can use it for whatever you want to use it for. So we also have another type of georeferencing, which is image-based georeferencing. So with this, you just need an image. So let's say that you have a particular community, or you want to use any of the institutions, be it KNUST, be it UBIT, be it UDS, or any of the institutions, maybe educational institutions that you want. So you just get a map, or you just take an image, be it a drone captured image or however you are going to capture it. So you align that image with the real world context. So that means that you are going to open to the area that you have an image from. So you generate control points on the image and align it to that of the real world context, as you can see in this image. So we'll be doing something related to that, and it will help to get a better understanding of what we are talking about. So it's almost all the same, like comparing that with a coordinate base, because you still have to generate some points, though the coordinate is not something that you already have as control points, but you are going to align the image. And in aligning it, you create those control points. Yes. So I think with the coordinate system, Majid already said a lot about it. If you don't select the right coordinate system, at the end of the day, where your work or your project is going to lie is not going to be maybe where you are anticipating. So let's say that you select um if you want to use WGS 84, that means that you are looking at it in a broader perspective. So it's going to cover the whole entire world. But when you're using geographic, and that's UTM, it's being projected. That means you are looking at a particular specific area. And also, when you use maybe not the world context, if you use WGS 84, that means that you are more likely to still get what you want, but it will be in a 3D format because in projected it normally gives you in a 2D format. So there are various types of geographic coordinate systems, and then in georeferencing, it's also important that you select the most appropriate projection system or coordinate system so that you can be able to work with your data set very well. So as I was talking about this, the projected coordinate system, having it in UTM, having your X and Y coordinates, and it provides you a presentation in a 2D map format. So that is what we should know. I hope you get that. Please, do you
Yes,
get,
please.
I hope you understand, please.
Yes, please.
These are the type of transformations that I was talking about. So we have the affine, which is first order polynomial transformation, and these are some of the features that it comes with. So in terms of mechanics, like it preserves straight lines through scaling, rotating, translating, and steering. So usually when you want to use the affine or the first order polynomial, you are going to use three control points or maximally, or the number that is recommended is four. So you are going to use four control points to do your activities. So I think that's one of the major things you look at. And looking at some of the advantages, it is very simple, efficient for basic adjustments and low computational complexity. So when you are doing it, you are not going to calculate anything that is going to give you a headache. It's just something that is very simple. So this is also for second and third order polynomial. So you are going to use at least six control points. And then maybe if you are using the third order or third polynomial, then you are going to use about 10 control points to be able to do your analysis or to get a better georeferencing. That means that when you use that, you are going to align your data sets to the real world in a very perfect manner, or that will give you the best results you are looking for. So these are still some. We have the spline transformation and so on and so forth. So, but what we are coming to look at, we are just going to use the affine, or we go by linear. That is very simple for basic stats. So what we also need to know is that there are some errors that are associated with referencing that you need to take into consideration when you are trying to do georeferencing. So positional error. So let's say that you want to use image-based georeferencing. If you don't take your time to align your image properly, at the end of the day, you are not going to get the best results. So positional errors is very rampant when it comes to georeferencing, and it's something that we need to take note of. Then also digitizing. So let's say that a particular scan map we're having has gone through some digitizing, and that there were certain errors. So the moment you want to align it to the real world context, once there were some georeferencing errors, it's still going to affect your map. So if you want to use a particular map, you need to check that it is the original map. Nothing has been done on it, whereby you can have issues like digitizing errors that will affect your, your georeferencing or whatever that you want to use it. So map projection distortions. So that is one thing we were talking about in relation to the transformations that we use. So if you don't use the appropriate projection and transformation, is going to affect your map. So errors arise from transformation of curved surfaces. So let's assume that you are going to use not UTM, but you are using maybe WGS 84, which presents the Earth in a 3D format, giving you some curvatures. So if you use tertiary projection, they are more likely to give you errors. So that is something you need to to take into consideration. Then also the GPS devices that are also used for surveying. Let's say that you want to take some coordinates for control points. If you take it in such a way that it wasn't very accurate or there are some inconsistencies in them, when you want to use them as a ground control points, it's going to affect your work. Then we also have temporal errors, that is using outdated data or incorrect time stamps. It's also more likely to give you inconsistencies in your spatial data. That is going to affect the outcome of your results. Then data entry error. If you mistakenly put any wrong coordinates as a control point, then it will affect your what? Your georeferencing process and the end product you are going to have. So that is another thing you need to take note of. So we also have scanning errors.
Okay.
We also have scanning errors. So if your scanning is having a problem, then that means that definitely you are going to have problems. So let's assume that in the process of scanning, there were some mistakes, or let me say that some details were not well shown, and you want to use it to georeference. There definitely you are going to have misalignments. So it's something you need to take very keen note of. So whenever you are going to scan an image for georeferencing, you need to make sure that you have the best camera or the best scanning device to do that. That is if you want to use it for a high importance project. Then we also have control points or selection errors. So if you are doing image-based georeferencing, the moment you are not able to detect a particular location very well to establish a control point, then that means that in your selection, you are having inconsistencies. It will definitely affect your work. So that is something you also need to look at. Then we also have some logic errors, inconsistencies in spatial relationships between features, such as overlapping and misplaced objects. So that is something you need to also take note of. Logically, when you are doing it, you have to make sure that you are consistent in all your georeferencing activities. So I have something to note. So to minimize these errors, careful selection of control points, high quality data sources, and rigorous validation techniques are essential. So it's something that you would have to take note of so that you'll be able to look at it. So this is just a basic thing that I want us to look at when it comes to the control point selection. So you realize that when you look at this, you have about 3 to 6 control points, and that is very low. And you also have 10 to 6 to 10 moderate, and N to 1 ratio, which is very high. And mind you that whenever you are using this control point, the number of control points you use is something that is going to take a lot of time and will also impact your work in terms of cost efficiency. So that is something you need to take note of. I think we have some 10 minutes left. So what we do is to head over to our QGIS so that we can practically look at what we are talking about. I hope that is okay. Can you hear me?
Yes, please.
Yes. So
Let's go ahead.
we are going to open our QGIS so that we practicalize what we just briefly looked at. So I'm switching to open my QGIS, though we have some little minutes left. I hope you can see my GIS interface.
Yes.
All right. So we are going to look at we were talking about the training data. So that is what we are going to use. So what we are going to do right now is we are going to look at coordinate-based georeferencing. So what we are going to basically do at this time is we will first use um, some grid coordinates. When you prepare a map, you realize that there are always some what? There are always grid on it, isn't it? Things have been provided. That is what is going to help you to be able to georeference it at any point in time. So when it even becomes old, but if you still want to incorporate some data into it, then you can still georeference it and use it to do whatever activity that you do. So now what I want us to do, first of all, go to this particular plugin, which is HCM GIS, so that we can incorporate a base map. Then we add the raster image that we are coming to look at. So we just go to Google Hybrid and incorporate it. Then we look at, we switch to Ghana. I think so. Now let's go to our data source manager. Then we go to browse. Then you go to the directory in which you saved your work. So go and so I have training data here. So now I go to georeferencing. There is a particular folder that is labeled georeferencing. So you click on Ayerede Community Intervention Map. Ayerede Community Intervention Map. Then you open it. So I hope you've incorporated your raster data. So don't mind the question mark that is on it. But I hope you can see. So what we need to do is let's try to zoom to layer to see where the image is. Can you see where the image is? So you can all see that the raster data is inside the sea. So now what we are going to do is that we are going to georeference it. So we need to go to our layer, then we go to georeferencer. So once we go to georeferencer, now we go to open raster so that we add the raster again, then we start our georeferencing. The first one that we incorporated into the workspace is for us to determine the current location of the image. Do you get that?
Yeah.
So when it gives us the opportunity to georeference and see its new location, so we go to add the image. So I've added the image. So now for us to add control points, we will need to determine where we want to put the control points. First of all, we added the image, and we loaded it into the workspace, the work interface. We realized that
Yes,
this is a
I have
community.
this one.
Okay, then you realize that it is in the sea. So now what we want to do is that
Yes.
we want to add it to georeferencer. So we go to layer, then you go, yes. So so once you open your georeferencer, what you need to do is to go to look into the image, the raster image that you have put in place. You identify various intersections of the grid lines. So that is where we are going to use, because we are going to use the X and Y coordinates, and that will help us in the georeferencing process. I hope you get that. So we are going to start from this particular point. I hope you can see where my cursor is.
Yes, please.
Usually when you open the georeferencer, it's usually on add control points, and that is on this option. You can see that its background has been changed to something like grayish. So that means that it's being selected. And when it's selected, you have this plus sign that we are using. So you head over to maybe probably to zoom it so that you can get the correct intersection. So you click on it, then enter the coordinates manually because we can't draw from canvas because the image that we loaded is not having a real world context, or we don't have this map in maybe the base map that we loaded. This is a map that has been prepared for a particular specific purpose. So we need to enter the grid coordinates that have been provided. So usually with X, you are going to enter the longitude coordinates that are on it. So we are going to have 6, 4, 8, 0, 0, 0. There's no need to add the point 0, 0. I hope that is clear. Then
Yes.
the Y, you are going to put your latitudes over there. So you are going to have this particular number there, which is 82, 9, 0, 0, 0. Then you click OK. Then you go to, we are going to use linear transformation. So we have to do them linearly. So we move to this particular set of grades. Then we determine its location, like the exact spot, so that the middle of the cursor will be in the intersection of the two grades. So we click on it. Then we are going to put our X and Y. So we said that our X is going to be our longitude. So we have 6, 5, 1. Then we have 0. We have this only one. So we have 000. I hope that is okay.
Yes,
So
please.
then we go to put our Y. So we have 82 and we have 9,000. So we hit OK. Now we go to this other section where we have another set of grades meeting over there. So we have place 1 here. All right. So we put our X, which is going to be 651,000. Then we go to our Y, then we have, let's shift this to get the number correctly. So we have 826,000. Then we hit OK again. So we are going to use 4 control points. So we have another one here. Right. So we also enter our 6, for which represents our X. 8,000. And our Y we have 826,000. And okay. So now you go to this kind of this particular icon, then you have transformation. That is where you are going to use to set your transformation. And I said we are going to use linear. So mine is already on linear. So this is the polynomial that I was talking about. You see, we have 1, 2, 3, then we have template, spline, then projective. So we are going to use linear. So you click on linear, then you set your CRS, that's the coordinate reference system, to WGS 84, that's UTM zone 13 off. We are using the projected coordinate system. So once that is being set, you go and click on OK. And now we hit on georeferencing. Our image has been georeferenced. So now what we will do is that we go back to our work interface and then we realize that we have 2 images being named the same thing. We have already community intervention modified. So this is the original image and we can see where it is found in the sea. So that is not what we are now interested in. We are going to look at our georeference one, which is what? Modified. So now let's click on it and zoom to layer. It has moved from the sea to a particular location found in what? Ghana. Can you see it? It has moved from the sea to a particular community in Ghana. So if we look at the map label, they are saying that an intervention map of Ayerede. So let's try to look at the hybrid map that we have. So let's first of all try to uncheck it and see where it is. You can see Ayerede. So if we check it in, you realize that it's in that particular community. And that is a map that has been prepared for the community, trying to bring some interventions. So now what we can do is that we can go to um we can go and open either from the properties aspect, or we can go to style panel. Then we go to try to reduce the opacity by going to transparency. So when you go to transparency, then you can be able to reduce the opacity so that we can try to see it match with that of the hybrid satellite lease map. So I think it's still quite good. So we can still further reduce it. Right. So I hope you can see it. And you can see that everything is aligning perfectly, because if you look at the image, you can see that this is a water body, and we can see it's still lying there very clearly. And we can also see it over here. So if we want to increase the opacity more to see it much more clearer. All right. So you also see that this particular place has been defined as a residential area. And if you look at it, you can see that that is where majority of the buildings in the community are found. So let's go to properties and then still go to reduce and try to increase this more so that we can perfectly see that. Can you see it? And these are some marshy areas, water lock areas, and some other land uses around it. So these are some of the interventions that they brought in place, and we can see them. I hope you can all see them. Please, can you see?
Yes, please.
Yes. So that is how georeferencing is done. So now let's look at another method whereby your control points are being stored in a KML file. That means that your control points were generated from Google Earth. So you want to see how you can incorporate that into your workspace and then georeference. So now what we are going to do is that we are going to remove what we have done so that we can load and have a clean space for that activity as well. So now you head over your layer, then you go to data source, then you now go and load this particular Ghana satellite. So you load that image, and we will use what we are going to do. So now let's try to see the current location of the image. So I hope you can see that that particular image is found in the what? It's also found in the sea, isn't it? It's also found in the sea. So now we are going to see
Yes.
how. So this one we need to be very observant, because we are working with a hybrid image as well. Like this is a satellite image that was being captured from Google Earth. And what we are working with on our work interface is also quite something similar. But you realize that this one is having white boundary linings. And this is also having yellow boundary and labelings. I hope you can see that. And these are our ground control points that are being generated. That is what has been generated as our control points. So now what we need to do is to load our control points. Right. So we go to add layer, then we go to add vector. So this time around we are going to add vector. This is not a raster layer. So we have our ground control point there. So we hit on it, then we click on open, then add. So we are going to add it. So close. You can see your control points here. So let's try to zoom and see where they are going to be located. Can you see them? Can you see these boxes? Can you see them? Please, can you see this? So let me try to do some labels on them. So I've shown label on them. So you can see your control point 1, then 2, 3. Now let's go to layer, then we go to georeferencer. What we are going to do is to remove what was already there. We are going to discard this. Then we add our image. So we have opened the new image that we are going to georeference, which is the Ghana boundary. So now what we need to do is that this time around, once we have the coordinates or the control points on our real world database or map, we wouldn't need to be entering them manually. All that we need to do is to just draw from canvas. So we will come and click here. If your own is not on add control points, you come and click on add control points. Then you can zoom to this particular point so that you have the middle part of this. So now you click on from map canvas because we already have the control points loaded in our workspace. So we are drawing from map canvas. So this is our control point 1. So you come and click on it. Then you click on OK. Now you go to control point 2. Then you come and click on it. Then you add from map canvas. Then you come and click on it. You add OK. So you also go to your third control point, then you click on it, then you click on draw from canvas, then you come and click on it here, and you add OK. So it's the same thing you are going to repeat. So you exhaust all. So we are now moving to our control point 4. So you come and click and add it as well. Then you hit OK. So all that you need to do now is to, because we already use the transformation types that we want to use, like the previous one, unless you are using a different map altogether. So let's say this one, because we are looking from it at a world perspective, let's change it to WGS 84. Then we go and click on OK. So now we run it. It has been georeferenced. So now what we need to do is to close our. So if you want, you can save your control point so that you can use it easily. But if you don't want to, you can just leave them and continue your work. So now let's look at the current location of the one that usually after georeferencing, they will tell you that the raster that you initially added has been modified. Has been modified. So you click on that one and you go to zoom to layer. So what can you see? Have you realized that it has aligned to the data the real world context? Can you see that?
Yes.
Yes, it has been georeferenced, so it has aligned perfectly with that of the real world. So if you want to see that, you can just try to switch off this, then see. So you can realize that it's matching with the real world context, which is having a white lining. So that has already been completed. So that is how georeferencing is done. So now let's look at another perspective where we talk about trying to georeference an image, like image-based georeferencing, where you need to identify some reference points as your control points, then you do your what? Your georeferencing. We are going to switch from Google Hybrid. So let's just, maybe we can just say new project. So discard the original, what we were having initially. Then we go to our HCM. Then we add another base map, which is Ayerede topography. I hope, did you see what I just done? I said we are not using Google Hybrid again, but we are going to use Ayerede topography. That will give us a good perspective of what we are coming to do now. So right now, you can all zoom to, if you're following with your PC, you can zoom to KNUST. We are going to do an image-based georeferencing of KNUST map. Do you get that? So you switch your base map from Google Hybrid to Ayerede topography. So now what we all need to do is to head over to our layer. Then now let's look at where the image is. Can you see the image?
Yes.
Yes. So you realize that KNUST, the image I just loaded, or the raster data I just loaded, is in a particular space where they are saying that map data gets not available. So now what we are going to do is that we are going to make sure that we georeference this image and make sure that we have it around KNUST. So now what we need to do quickly is to go to our georeferencer, discard this, and then you go to add your KNUST map over there. So you have it here. So now what you need to do is go to your add control point, which is already marked. So now what we are going to do is to make sure that we add control points in specific places that we know, and we can also see them perfectly on the real world context. So now let's go to zoom to the Ayerede topography map.
Yes.
All right,
Yes.
that's fine. So now we are going to add the KNUST map again. So now what we're going to do is that we are going to, first, initially we had its original location. So now what we're going to do is just to go to our georeference and add it. So you know where to do that. We go to,
Yeah.
so we look at this particular edge, then we add a control point over there. This one too, we are not adding, we are not going to add any coordinates manually. We are also going to draw from canvas. But mind you that we didn't add any initial what? Control points like we did for the Ghana map. So now what we need to look at here is to go to Kumasi and then look for where KNUST is. So this is where KNUST is. And this is where we are trying to place our first point from the raster data. So you come and click here. Make sure you place it perfectly. So we click here, then we hit on OK. Then we find another place. So let's assume that we know here, a V shape here. So let's come to the top of the V shape. and add another control point. Then we go to draw to canvas. Then we have it over here. So we then add OK. Then we also add another one. So we can go to this point and add another one. So draw from canvas. Then we go to do for it in the real world context. So we can put it here, this particular tip here. And we say OK. So we are going to use 4 control points. So let's add the last one over here. So we come in place, the last one over here, then we also draw from canvas. So the last one is here. So we hit on OK. So we can go to our transformation and also try to check everything is still over there. Because we've used it a number of times. Once you use it, definitely it will still provide you those informations. Depending on you, if you want to change or you are doing a different project, then you can change it. So we just hit on OK. Then we come and run georeferencing. So you realize that they are saying that the layer was what? Successfully georeferenced. So now let's go to look at it in the real world context and see as to whether that is aligning. So can you see that now the image is around KNUST, it's in Kumasi. Let's try to find out. So let's try. Can you see it? Please, can you see it?
Yes.
Yes. So you realize that we have also used another method, that is the image-based georeferencing, to successfully georeference KNUST map. So with this, if you want, you can go to the data, either you can go to properties to change the opacity, or you can go to the style, the layer styling. Then you can go to transparency, then you reduce it a little bit to see how perfectly it matches with the real world data. So you can see it. So one of the things you can use to detect as to whether it's correctly georeferenced is some other locations. For instance, you can see that you can see the KNUST Botanical Garden. Can you see that? Can you see the Botanical Garden? I think that is
Yes.
that's one of the key areas. So now if you try to switch and compare with the real world, that is the Ayerede base map that we loaded, the topography that we loaded. So if you switch on and off, you can realize that the botanical garden is matching perfectly with that of georeference data. And the outline of KNUST boundaries is also matching with that of data that we just incorporated now. So that is how georeferencing is done.